Welcome to this GCSE Chemistry revision video focusing on electrolysis. This topic can sometimes be confusing, but this video will break down all the essentials, from basic definitions to half equations and practical applications. Electrolysis is the process of using electricity to break down a substance. More precisely, it decomposes an ionic compound in its molten state or dissolved in water using a direct current of electricity. It's an industrially important, non-spontaneous process, requiring electrical energy input to drive the chemical change. An electrolyte is a substance that conducts electricity and can be decomposed. This is an ionic compound that is either molten or dissolved in water, allowing ions to move freely. Covalent compounds, or solid ionic compounds, are non-electrolytes because their ions are not free to move. Positive ions are cations and are attracted to the negative electrode, the cathode. They gain electrons, which is called reduction. Negative ions are anions and are attracted to the positive electrode, the anode. They lose electrons, which is called oxidation. The cathode is the negative electrode where reduction occurs, meaning positive ions gain electrons. The anode is the positive electrode where oxidation occurs, meaning negative ions lose electrons. Remember the acronym oil rig: oxidation is loss, reduction is gain of electrons. When a direct current is applied, cations move towards the cathode and anions move towards the anode. At each electrode, ions gain or lose electrons, converting them into neutral products released as solids or gases. Electrolysis of molten compounds is simpler because only the compound's ions are present. The general rule is, metal is deposited at the cathode and non-metal is produced at the anode. For example, in molten lead bromide, lead is deposited at the cathode and bromine gas at the anode. Molten lead bromide is a classic example. When melted, Pb² ions move to the cathode, gain 2 electrons, and form liquid lead. Bridge ions move to the anode, lose 1 electron, and form bromine gas. Remember, the lead bromide must be molten to conduct electricity. Aqueous solutions are more complex as water introduces H and OH ions, creating competition at each electrode. Golden rules apply based on the relative reactivity and concentration of the ions to predict the products. At the cathode, metal cations compete with H ions. The less reactive species is discharged. Metals below hydrogen in the reactivity series, like copper, are deposited. For metals above hydrogen, H ions are discharged, and hydrogen gas is produced. At the anode, the salts anion competes with OH ions. If halide ions are present, the halogen gas is preferentially produced. If no halide ions are present, oxygen gas is produced from the discharge of OH ions or water molecules. Electrolysis of brine, concentrated sodium chloride solution, simultaneously produces 3 valuable products. Chlorine gas forms at the anode, hydrogen gas forms at the cathode. Sodium hydroxide is left in the solution. Chlorine is used in bleach and plastics. Hydrogen is used as fuel and to make ammonia. Sodium hydroxide is a strong alkali used for soap, paper, and as a cleaning agent. Learn at least one industrial use for each product for exams. Half equations describe the reaction at a single electrode, showing electron gain or loss. Write the ion and product, balance atoms, and then balance the charge with electrons. For reduction at the cathode, electrons are on the left. For oxidation at the anode, electrons are on the right. The required practical involves setting up the circuit and observing gas bubbles or solid deposits. Test the products. Chlorine bleaches damp litmus paper white, and hydrogen burns with a squeaky pop. Record observations and link them to the half equations. Key variables in electrolysis investigations include the independent variables you change, such as current or duration. The dependent variables you measure are typically the mass of metal deposited or the volume of gas collected. Control variables, like temperature and electrode material, must be kept constant for a fair test. A common error is failing to dry the cathode before weighing, which leads to inaccurate mass measurements. When predicting products, first determine if the electrolyte is molten or aqueous. For half equations, balance atoms first, then use electrons to balance the charge. Remember, for solid ionic compounds, it ions, not electrons, that carry charge in the molten or aqueous state. When explaining conductivity, mention that ions are held in a fixed lattice in a solid, but are free to move when molten. For brine, remember the specific uses of chlorine, hydrogen, and sodium hydroxide, and know the relevant half equations. Crucial exam tips include correctly identifying the cathode and anode, and remembering the rules for aqueous solutions. Always check that your half equations balance both atoms and total charge on both sides. Also, remember that halogens are diatomic.